Well, dear students, there are a few questions here in this video which have been asked in competitive exam. So I will try to explain you. The first question here is the extension in the stretched string obeying Hooke's law is x and speed of transverse wave is v. If tension in the string is increased to 1.5x, then speed of transverse wave will be 1.22v, 0.61v, 1.50v or 0.75v. So we know speed of transverse wave is equal to under root t by m. T is the tension in the string. As we know from Hooke's law, F is equal to kx. So tension T here is the force applied to stress. So V is equal to under root kx by m. Then V dash nu V will be under root k into 1.5x as extension means increase in length. If we stretch a wire, then we apply force and then the string applies restoring force is equal to kx upon m. So V dash upon V left only under root 1.5 only. So V dash equal to V into root 1.5. Root 1.5. Here is the problem. Actually, before decimal pair are formed this way, and here we can put as many zero, and pair are made this way. 1 1 ja 1. 0.50. It is 2. 2 2 ja 44. 6. Then 2 0. 4 and 2. Again 2 ja. So it comes out to be 1.22v. So our first option is correct. Please improve your mathematics. Arithmetic, we are not serious about this learning. Okay, we forget. That's why I keep on telling you. Now, second question is a good question here. Has been asked in JEE mains. This question has been asked in JEE mains. JEE mains in 2016. The uniform string of length 20 meter is suspended from rigid support. A short pulse is introduced at its lower end. It starts moving up. The time taken by it to reach support is 2 seconds, 2 root 2 seconds, root 2 seconds, or 2 pi root 2 seconds. A uniform is length 20 meters. This length 20 meters, nothing else. And here we produce a small pulse here by giving circuit. So that start moving. So time taken by the pulse to reach support. So here this string has 20 meter length. You know its total mass will be acting downward, that at a center mass. So tension will keep on changing. As we know, V is equal to under root T by M. Here T tension will be produced only due to weight of the string. Weight of string is responsible for tension in the string, and that will increase the length increases. So if M is the mass per length, and so T can be written as M into xg upon M as the distance traveled. So here it comes out under root gx only, v, And we know from definition of velocity v equal to dx upon dt equal to root gx, or you can write it as dx upon root x by square root g or into root x. You can write like this. So dx upon root is equal to under root g dt. Now if we integrate it from 0 to x and time 0 to t, so integration dx upon root x 0 to 20 मीटर है, टोटल लेंथ लिखेंगे बाद में, एल टोटल लेंथ है, और रूट जी और अंडर रूट डी टी 0 to t, 0 to t. You can write it as x to the power minus half dx dt. तो इंटीग्रेशन x पावर n dx x पावर n plus 1 upon n plus 1, so it will be x to the power plus half upon half or 0 to l, sorry, जी तो कांस्टेंट है t 0 to t. Formula I have used this one. So now sorry 1 by 2 here. So 2 into x to the power n to the power half is equal to g under root t. L is 20. So t equal to 2 into root 20 upon under root g. Under root g is 10 root 20. L is 20 meter na, upon root 10, so it is 2 root 2. Here the length L of the string is given 20 meter there, so that way it is correct. B option is correct here. I hope you have got my point. So please don't avoid these questions. Such questions are asked in competitive exam. And dear students, whosoever you are learner or trying to crack any competitive exam, you have to understand this. Now I will take more questions here. Yes, dear student, question here is this: a rope of length L and mass M1 hangs vertically from rigid support. A block of mass M2 is attached at its free end. The transfer pulse of wavelength lambda 1 is produced at the lower end of the rope. The wavelength of pulse when it reaches the top of the rope is lambda 2. The ratio lambda 2 upon lambda 1 is under root m1 upon m2, b under root m1 plus m2 upon m2, c under root m2 upon m1, and c m1 plus m2, m1 plus m2 upon m1. So situation is like this: the rope is attached to this support, its length L, here its total mass M, and weight below mass m2 here. So when we produce a pulse here, then it reaches here, and as it reaches, tension keep on increasing. Actually, if the rope uniform, so mass will be acting at center mass m1 here. So here tension, suppose it is T1 here, it is T2. Here T1 will be m1 plus m2 into G. And here T2 is equal to m2G, suppose like this. Velocity transverse wave V equal to under root T upon M. And remember, when a wave travels in same medium, velocity depend on tension, so velocity will change here. Velocity will be changing, but frequency does not change. You know V equal to L lambda. I have told many times that velocity is not only the function of frequency or wavelength. It depends on wavelength and lambda, but overall velocity transverse wave depend upon tension and mass per length. Velocity depend on this, and if velocity changes in one medium, frequency does not change. Remember, this is a very important fact. If velocity of wave in a medium changes due to some changes, frequency does not change. So here it is lambda 1 wavelength, here it is lambda 2 here. So n into lambda 2 will be under root tension is there, m1 plus m2 into G upon this m1 is the mass, total mass of this. No, m1 by l, sorry. Its length is l. Then n lambda 2, sorry, n lambda 1 under root m2g upon m1 upon l, mass per length. Mass per length will be total mass divided by length, L. Now dividing this by this, lambda 2 upon lambda 1. Hence, these two get cancelled, G get cancelled. It is left only m1 plus m2 upon m2. So option B is correct. This is a very informative question. It is also, I should say, a good question, and give information here that when any wave pulse or wave travel from one end to another in a medium, the speed of wave may change, but frequency does not change. So wavelength will change. Thank you. Next question I will be telling you here just now. Well, dear students, here is another question. The equation of wave in a stretch string of linear mass density 0.04 kg per meter is given by y equal to 0.02 sin 2 pi t upon t, t upon 0.04 x upon minus x upon this meter. The tension in string is, this is the equation of wave in a string. You know, in stretch string the wave will be transverse wave. Velocity transverse wave is equal to under root t by m. You are given m, you are asked t, so you should know what is v. From where you will get velocity of wave. The question keep on wandering in the brain. Simple is there. Question answer is that V equal to N lambda. From this equation you can find out frequency and lambda by comparing this equation with y equal to a sine 2 pi t upon t minus x upon lambda. From here frequency n equal to 1 by 2, 1 by t equal to 1 upon 0.04 is equal to 100 upon 4, 25 per second. And then 1 upon lambda is equal to 1 upon 0.05 meter. So lambda is equal to 0.5 meter. So V equal to N lambda. यानी कि 25 into 0.5, 12.5 meter per second. Use this velocity 12.5 meter here. तो क्या मिलेगा हमें? 12.5 is equal to under root t upon mass to length 0.04. Squaring both the sides. 12.5 into 12.5 into 0.04 is equal to t. So how to solve this? Actually, you have to use commutative law and others. Don't get perturbed. 25 into 25 into 4 upon 10 into 10 into 100. 25 5 ja 4 ja cancel. So it is left only 5 5 ja 25 2 or 12 5 is 62 upon 100 means 6.25 Newton. So how to solve the problem easily? This is one way. So which option is correct? A option is correct. Well, dear friend, there is another question here. If N1, N2, N3 be the fundamental frequencies of three segments into which a string is divided, then its original fundamental frequency N of the string is given by these options: 1 upon N equal to 1 upon N1 plus 1 upon N2 plus 1 upon N3. 1 upon root N equal to root 1 upon root N1 plus 1 upon root N2 plus 1 upon root N3. And C root N equal to N1 ratio root N2 ratio N3. And N equal to N1 plus N2 plus N3. See, suppose this is a wire here. Is stretched between 2 and its total length BL. So fundamental frequency तो 1 upon 2L under root T by L. This is the fundamental frequency. Now if this wire is divided into three parts anyway of length L1, L2, L3. So L1 part has frequency N1. N2 part length segment has frequency N2 and this much length has. But remember here L is equal to L1 plus L2 plus L3. From this equation, actually 1 upon N will be 2L under root M by T. Similarly 1 upon N1 will be 2L1 under root M by T. Tension remains same. 1 upon N2, 2L2 under root M upon T. 1 upon N3, 2L3 under root M upon T. Now if you add these three, what you will get? I am rubbing this. You will get, on adding these 1 upon N1 plus 1 upon N2 plus 1 upon N3 is equal to 2L1 plus L2 plus L3 or under root m by t common to, or when you add, it is equal to 2L under root m by t. And what is this? It is 1 by n. So which one correct? 1 upon n is equal to 1 upon n1. So option A is correct. Option A is correct. What I did by fundamental 1 upon n equal to 1 upon 12 into 3 by m. L is equal to L1 plus L2 plus L3. So 1 upon n, this from this 1 upon n is equal to कर दिया. So 1 upon, similarly 1 upon n1 2. Adding them we get that thing. So I hope you have got this point. So these are some questions in this video which are important for you. Dear student, please cover the whole syllabus. I have noticed, I have told you many times, a student remains engaged in learning mechanics part, Newton law of motion, work, power, energy, rotational motion. They are the difficult part of this physics for you. For learner, these parts are difficult. So please, wave chapter is simple. You can do it well. So take care and learn the last topic also. I am again requesting you, please cover the whole syllabus to crack any exam. Which part you don't understand, easily avoid that and start learning first the part which you can do well. Thank you. Please like the video, share the video and ask your friend to subscribe my channel.